Okay, today is January 17th, 2012. For your review, on page 530, there are 34 questions that cover from Chapter 1 to Chapter 8. They're split up. Chapter 1 is the first 5 questions. Let's see if we can actually put it out for you here. Let's pause this. So that's the breakdown. Chapter 1, 1 to 5, 2, 6 to 10, 3 is 11, 12, 4 is 13, 14, 5 is 15 to 17, 6 is 18 to 24, and then 7, 25, 30, 8, 31, 34. So, alright, so we're going to jump ahead to the test. We're going to work on question number 3. So question 3 says, Laura wants to build an outdoor swimming pool with an area of 49 meters squared and a minimum perimeter. Which shape should she use? So which will maximize area, minimize perimeter? Which shape, Alex? For a 4-sided shape, it's a square. Yes. A circle is going to be the most efficient of these shapes. Okay? So we were looking for A in this question here. Okay, so these are the 2 major shapes we're going to use to prove it, just to see that if a circle does have a smaller perimeter and a larger area in terms of its size. Okay? So, our square, the area of a square is A is equal to the sides squared. Or in other words, one side times the other side. Since they're all the same length, we would just multiply the 2 of them. So in order to figure out how long one of the sides are, we're going to plug in the area they've actually given us, which is 49. We're going to plug that in for our A. So we get 49 is equal to S squared. To figure out how long a side is, I have to isolate S. So what would I do to both sides of these equations to get rid of that power of 2? Square root, good. So you square root both sides. How long is each side of this square? Perfect. So we're looking at 7, is it meters, centimeters? Centimeters? All right. 7 centimeters is the side of one of these. So now we're going to calculate the perimeter of this object. Our perimeter is P is equal to 4S. We know the S is 7. So the perimeter of this shape is equal to 4 times each side. Our perimeter would be 28 centimeters for our square. Small. Let's see if our area of our circle is a little bit better. Oh, is it meters? Okay. That would be a very small pool. Yeah, change that to meters. Okay, same idea with the circle. Maybe it's a pool for a bird. Okay, area again. Again, this is going to be 49. We're working with that one constant. The area of both of these shapes is 49. We want to minimize perimeter. So we need to find out the radius of this circle, okay, in order to find out the perimeter. Our R is what we're going to be looking for. So we plug 49 in for our A again, is equal to pi R squared. So pi is actually a number. So in order to isolate the R, I need to move pi to the other side of the equation. So we're going to get 49 is equal to R squared. And 49 will be divided by pi. Okay? So we're going to do that with our calculator. Put it up. We get, oh jeez, I cannot see that. I cannot see that. So when we divide those 2 numbers, we get 15.59 is equal to R squared. I still have to isolate for the radius. So again, what do? Square root both sides. This time we're going to get R is equal to, take the square root of that answer, 3.94. That is just the radius, 3.94. That's a 3. Okay? So our radius is 3.94. The perimeter of a circle is 2 times pi times the radius. Okay? So we're going to plug in our R into this equation to find out the perimeter of this circle and see if it's smaller than the square. So the perimeter is 2 pi, and instead of R, we're going to plug in our value of 3.94. Okay? we're going to multiply 3.94 times 2, 7.89, or 7.88 times pi. Sure. 24.8 meters. So when we take a look at this question, the square has a larger perimeter with the same area. So the most efficient shape we had was the circle. So if you're ever building and materials cost you money and you're trying to maximize area of something while minimizing the perimeter or the materials, like a fence you would need, a circular fence would give you the maximum area while having to use the least amount of materials or perimeter. Okay? Now for a four-sided shape, a square is the most efficient. Okay? It's more efficient than a rectangle. Okay? Thinner or longer. A square will be the most efficient. But between the two of them, a circle is better. Okay, so let's read this question. It says that a shed is being built in a backyard. Oh, what happened to this picture? The front has two congruent circle windows of a radius of 30. Okay, so what I'm going to do is I'm just kind of fill this in as we're going here. The radius of one of these circles is 30 centimeters. And an asymmetrical roof and a door in the center. Determine the area of the front of the shed in square meters. Round to 2 decimal places. Do not include the door in your calculation. So we're going to have to fix this picture a little. So we have our diagram. And we need to start figuring out the area of the front of the shed. So we have our diagram here. We need to figure out the area of the front of the shed. I wanted you to subtract the area of the circles from the front of the shed. One key point about this question, which I think almost all of you missed, is the answer was to be in a certain measurement. Does anyone remember? Meters squared, okay? The easiest way to do this would have been to convert everything to meters first, instead of trying to convert it at the end, which makes it much more difficult to do. So, I guess I'm going to redraw this in meters, and much larger this time. Okay. Pause this part. Okay, so we need to start converting all of the measurements into meters in order to get our answer in square meters at the end easily. The very first number we're going to deal with is from the high point of the roof to the end of the triangle, which was 150 centimeters. What would that be in meters? 1.5, exactly. So that is 1.5 meters. The radius of each of these circles with 30 centimeters, what would that be in meters? 0.3 meters is the radius of each of these circles. Okay? The length of the bottom of the shed was 240 centimeters. How many meters does that give us? 2.4. Good. 2.4 meters is the bottom of this shed. The height of the door, they give you the measurement over here, the other one was 240. The height of the door was 180 centimeters. What is that in meters? 1.8. Good. The height, not including the roof, was 228 centimeters. What are we looking at in meters? 2.28. Excellent. The width of the door was 60 centimeters. In meters, that would be 0.6. Good. I'm glad you guys know these measurements. We covered everything? I think so. So we've now converted everything to meters. The bottom. Yeah, we did the bottom. So we converted everything to meters. This way we can get our answer in square meters at the end. This will be the easiest way to go about doing it, so we don't have to do a large conversion at the end. Okay? So the first thing I'm going to do is I'm going to work on the circles because I want to take them out of the equation. We're going to assume that the windows are not included. Now, both of these windows, is there going to be a difference in their area? Are they supposed to be the same size? Yes, they are. The radius is the same, so both windows are the same. We only need to find the area of one of the windows. The area of our circle, okay, so the AC is 2, oh, what's that, right? Pi r squared. The radius in this is 0.3. So we're going to plug that in for our number here. Area of the circle is equal to pi times 0.3 squared. 0.3 squared is going to give us 0.09. 0.09 times pi .288, we'll say 3 meters squared. Okay, so the area of one of the circles is 0.23 meters squared. We'll highlight this so we know to go back to it as an answer. Okay, how many circles are there? 2. So how do I quickly figure out the total area of the windows? Add them together and multiply by 2. So the area of both circles, so we're going to call them 2 of the circles. That's not a good way to put it. Let's say 2 times it, so we'll put a 2 in front of it. The 2 circles, area would be 0.565 meters squared. Okay. Now, when I'm finding out the area of the shed, am I adding this to the area or subtracting it? I'll be subtracting it because I'm going to find the total area of this 4-sided shape, and then I'm going to get rid of the windows. It also says do not include the door in the question. So that means I also have to get rid of the area of this door here. Okay? Now, do I have the measurements for this door? I have the width, it's 0.6. What was the height? Good. 1.8. We put right over here. This is a rectangular shape, so it's pretty straightforward. We just multiply those 2 numbers by each other to find the area of the door. So, area of the is 0.6 times 1.8. 0.6 times 1.8. 1.08 meters squared. That's the area of the door. So the yellow ones, what we'll do is we'll highlight them as the ones we need to subtract from the total area. Okay? So these are all the areas we'll be subtracting from the total area of our shape. The next thing I'm going to do is I'm going to take care of the large rectangle. The face of the shed, let's call it. Not including the roof. Okay? I know that wasn't that well done. What is the width of this rectangle? What's the width of this rectangle? 2.4, thank you. And the height? 2.28. Again, it's a rectangle, so we're going to call it the face of the shed. We just need to multiply those 2 numbers. Area of the shed, we'll call it 2.28 by 2.4. 2 S's? Small shed. I don't think there's any other S's. We should be okay. I got it. 2.28 times 2.4. 5.472 meters squared. So this is one of the ones we'll be adding. I'm just going to highlight this a little different so that I can keep this organized. The area of the front of the shed is 5.472 meters squared. Now, hard part of this question. We need to find the area of this triangle here. Okay? Now the area of this triangle, does anyone remember the formula for an area of a triangle? Yes, half base times height. Okay? Now do we have the entire base of this triangle? From here to here? What is it? 2.4. It's the exact same as the bottom of the shed. Very good, okay? This number here is really irrelevant for what we're doing. It was kind of just there to confuse you, okay? This was what's important. So the width or the base of this triangle is still 2.4 meters. Now, here's the tough part, okay? Actually, I just realized it wasn't very confusing. You do need this. The height. We don't have the height of this triangle. So we have to go back to our trig rules. We do have this angle, 39 degrees, okay? And I can figure out this width. How would I figure out that base of that triangle there? Yes, 2.4, the base of the shed, subtract 1.5, which will give us 0.9, I believe. Let's double check. Yes, 0.9. So the base of this triangle is 0.9. Now that I have that, this is where we go back to our trig rules of a right angle triangle. I have the adjacent side, and I'm looking for the opposite side. What ratio would I use in order to solve that? Okay, so we're using our tangent ratio to solve this. Tangent deals with opposite and adjacent sides. So we had to remember our rules from chapter 1 in order to solve this triangle. So tangent angle is equal to opposite over adjacent. So our angle was 39 degrees. The opposite side was the height of the triangle. That's what we're looking for. And we discovered the adjacent side was 0.9. We need to move 0.9 to the other side so that x is isolated. So we have 0.9 multiplied by tangent 39 is equal to x. Times 0.9. The height of the triangle is 0.72 meters tall. Okay? So we need that measurement in order to find the area. So we're going to jump back up to the top. The height of this triangle is now 0.72 meters. So we got the base, we have the height, we just need the formula at the bottom, which Damien's going to help us with. What's the formula for area of a triangle? Good. 1/2 times the base times the height. Our base is 2.4. Our height is 0.72. So we're going to plug these in. We're going to multiply these together. 1/2 could be just 0.5 also. So 0.5 times 2.4, 0.72. The area of this triangle is 0.864 meters squared. So I'm going to zoom out for a second. I have a lot of measurements. I need to make sense of them all. Okay? 2.4 was the base of the big triangle, the whole one. Okay? So what we need to do here is we need to add up what we've highlighted in green. And what that is the area of the front of the roof and the area of the face of the shed. And we need to subtract the windows. We won't need to use this one. And the door. Okay? This was a complex question. That's why it was worth so much. I put the subscripts there so we know which ones to add and which ones to subtract. So we're going to put them in here. AT was 0.8464. Area of the shed. Anyone have it offhand? I'll go back up. 5,472. All right, so area of the shed, 5.472. Area of the door, 1.08. 0.08. And finally, the area of those two circles we did right at the beginning, 0.565. That's for both of them together. 0.565. So if you guys remember, this is how I highlighted things. The yellow is what we needed to subtract. That was the area of the door and the area of the two windows. And we're adding together. All right? Sorry about that. The green ones are what we were adding, the front of the shed and the triangle. So we put these all together. 5.472 plus 0.864, subtract 1.08, subtract 0.56. I think it was 6.5, wasn't it? It was 6.5. Is equal to, so 4.692 meters squared was the area of this shed. That was the final answer we were looking for. Okay. In-depth question, quite a lot to do there. So, this question says determine in meters. Sorry, we're going to stay in gallons because this is a very complex conversion. Ours won't be so complicated on our exam. Determine the dimensions of the rectangular prism with a minimum surface area that can hold 3,000 gallons. So that's our volume. Round the area to 2 decimal places. What 2 equations will you need in order to determine this? Well, we'll need the equation. Okay, and sorry, what shape? Let's clarify that first. What shape will give us minimum surface area, maximum volume, Jonathan? A cube. So a cube is going to give us, for a rectangular prism, this will be the most efficient shape, which means the area of a cube, anyone know what it is offhand? S cubed, good. And surface area of a cube. 6s, someone said it. Very good. 6s squared. The area of one side would be s squared, and there are 6 sides to a cube, so we multiply that by 6. Those are the 2 equations we'll be using, okay? Which equation will we need to manipulate first? We'll need to be able to manipulate the area first. Sorry, not area. Volume. We'll need to manipulate the volume first because we're talking about 3,000 gallons, okay? What variable we need to set in the equation. So we need to manipulate volume to get the measurement of a side. So to get a side, we're looking for S. Okay. Instead of setting up the chart, because we know what is the most efficient shape, we're just going to go ahead and manipulate these 2 equations. So the volume is 3,000 gallons, which means our V is 3,000 is equal to S cubed. How do I solve for S? How do I isolate S? The cubed root. So we did this with our exponents. The cubed root will be the fastest way to solve this. So, cubed root of S, or 3,000, sorry. 14.42. So that is the measurement of a side. Set up a chart to determine the dimensions of the shape. So each side of this cube, and we'll quickly make a cube here. Every side of this is going to be 14.42. Oh, we're in centimeters. Oh, I see, that's why. So, because this is in gallons, I did neglect to mention that, we do need to make that conversion we've put at the end here. So, 3,000 gallons, 1 gallon is equal to that many centimeters. We need to multiply 3,000 by 4, 5, 4, 6. 3,000 times that, 4, 5, 4, 6, times 3,000. Huge number. 13,638. This is centimeters cubed, okay? Centimeters cubed. That number is going to be equal to S cubed. So we're going to need to find the cubed root of that number. Just like we did 3,000, we'll need to find the cubed root of 13,638,000. That's cubed. In this case, S will equal 238.9. So the measurements of the cube are 238.9 meters. Sorry, centimeters, each of them. Well, actually, this is not that hard to put into meters at the end. Draw and label the diagram. Do they ask us for the actual surface area? What does it look like it? Oh, so this is essentially what they wanted us to do. What will this measurement be in meters? 238.9 centimeters. Anyone know what that is in meters? 238.9 centimeters? 2.389 meters. Good. That's the measurement of each side. 2.389 meters is the measurement of each side. And if it did ask us for surface area, we already knew the surface area formula was 6s squared. If each side is 2.389, we would plug that in. Square it. So 2.389 squared times 6. The measurement in meters, 34.24 meters cubed would be our answer. Oh, squared, sorry, surface area. Surface area is squared.